also known. And be able to classify these losses in order to implement effective countermeasures to eliminate them. Let's now go into the details of each loss. equipment failure. Breakdown losses occur when a machine breaks down and maintenance needs to repair it. How many hours a month are lost in the ward or on the line for this reason? Setup and adjustments. Today's world is characterized by a high demand for differentiation and small batch sizes. The production must therefore carry out type changes several times a month. But how long does it take for the type change if the molds are very heavy? What if there are many screws and bolts to screw in and out? What if the adjustments are very complex and can only be done by an expert? Idling and minor stops. When the pieces stop on a chute of an automatic machine, the operator solves it by himself and does not call for maintenance. This is a classic example of a minor stops. The sum of these minor stops, perhaps on several machines, can lead to a large loss of production capacity at the end of the shift. Reduced speed. Some plants, if not properly maintained, can meet the quality requirements only if they work at a speed lower than the nominal one. Process defect. Deeming said, defective parts are never free, someone pays to make them. It is useless to work, even with the utmost effort, if defects are produced in the end. Startup losses. A classic example of startup losses is when a machine needs time after being switched on in winter to bring the working oil to the right temperature. Now that you know the 6 big losses, you must learn to observe them, recognize them, and measure them correctly. When you have the measurements, you can calculate overall equipment effectiveness. For the definition of the OEE and how to calculate it, I leave you a series of in-depth videos in the description. Chapter 4. The 8 Pillars of the TPM. In the literature, a model of implementation of the TPM is often proposed with the figure of a temple with 8 pillars that must be built in order and in time. Following the road of the 8 pillars, we will no longer stop at the machines alone, but the improvement will affect the complete organization. You can find a slightly different order based on the source. Here I propose the sequence of the JIPM, Japanese Institute of Plant Maintenance. Pillar 1, Autonomous Maintenance. Operators who use all of their senses to help identify causes for losses. Pillar 2, Focused Improvement. Scientific approach to problem solving to eliminate losses from the factory. Pillar 3, Planned Maintenance. Professional maintenance activities performed by trained mechanics and engineers. Pillar 4, Education and Training. Support to continuous improvement of knowledge of all workers and management. Pillar 5, Early Management. Scientific introduction of equipment and design concepts that eliminate losses and make it easier to make defect-free production efficiently. Pillar 6, Quality Maintenance. Scientific and statistical approach to identifying defects and eliminating the cause of them. Pillar 7, Safety, Health and Environment. Scientific approach to solutions that will improve the safety, health and environment. Pillar 8, Office TPM. Using TPM tools to improve all the support aspects of a manufacturing plant, including production scheduling, materials management, and information flow. Chapter 5, TQM versus TPM. Total quality management and total productive maintenance are often used interchangeably. However, TQM and TPM share a lot of similarities, but are considered as 2 different approaches in the official literature. TQM attempts to increase the quality of goods, services, and concomitant customer satisfaction by raising awareness of quality concerns across the organization. TQM is based on 5 cornerstones. 1. The product. 2. The process that allows the product to be produced. 3. The organization that provides the proper environment needed for the process to work. 4. The leadership that guides the organization. 5. Commitment to excellence throughout the organization. In other words, TQM focuses on the quality of the product, while TPM focuses on the losses that impede the equipment used to produce the products. TQM and TPM can both result in an increase in quality. However, the way of going there is different. TPM can be seen as a way to help to achieve the goal of TQM. Chapter 6. The different types of maintenance. 4 general types of maintenance philosophies can be identified, namely corrective, preventive, risk-based, and condition-based maintenance. 1. Corrective maintenance. Maintenance is carried out following detection of an anomaly and aimed at restoring normal operating conditions. This approach is based on the firm belief that the costs sustained for downtime and repair in case of fault are lower than the investment required for a maintenance program. This strategy may be cost-effective until catastrophic faults occur. 2. Preventive maintenance. Maintenance carried out at predetermined intervals or according to prescribed criteria, aimed at reducing the failure risk or performance degradation of the equipment. The maintenance cycles are planned according to the need to take the device out of service. The incidence of operating faults is reduced. 3. Risk-based maintenance. Maintenance carried out by integrating analysis, measurement, and periodic test activities to standard preventive maintenance. All equipment displaying abnormal values is refurbished or replaced. In this way, it is possible to extend the useful life factor spread to the others, and then to other machines. Tip number 3. Plan adequate resources for maintenance. If you don't plan adequate resources in terms of people and spare parts, the first results you will get on the first machine